hit@gmail.com is my email address where I can post my manuals, my lectures, PPTs, and you have to submit your assignment also. And my mobile number is also there. So if you have any hesitation regarding that subject, please call me without any hesitation. Now, next, I'm going to discuss the syllabus. Basically, in your syllabus, you have 4 units: Unit 1, Unit 2, 3, and 4. Now, the journey will start from Unit 1. Here, first of all, I will discuss, first of all, I will discuss the introduction, basic terminologies of data structure, what data structure is, what are the operations can we perform on data structure, and so on. And in searching also, linear search, binary search, and the time complexity analysis. Okay, in my next next I will start to discuss Unit 4. Here sorting is there. So I think already you have implemented selection sort and bubble sort. Is it? Have you implemented? Anybody please response? Have you implemented any sorting algorithm?
No, sir.
No. Okay, fine. But as we have implemented initially using array, so it's very difficult to, very easy to understand. So that's why starting from Unit 1, where first I will discuss searching, and after that I will discuss some sorting algorithms one by one. That means bubble sort first, then selection sort, insertion sort, quick sort, merge sort. But heap sort, as heap sort, the structure of heap sort is something different. So heap sort I will discuss later. So after Unit 4, I will go to Unit 2. There I will discuss stack and queue, and then finally Unit 3, where I will discuss linked list and tree. So after completion of linked list and tree, I will discuss the rest part of Unit 4. So this is the way by which the entire semester will go. Next. Next, prerequisite. So for understanding or for learning or implementing the problems, you have to you have a very good idea about basic computation and principle of C programming. Already I have said you must have to write the functions, you must have to write the programming on array as well as pointer and structure. So if someone has some problem regarding structure, pointer, or array and function, please go through these 4 or 5 topics, because these are the very important things. Pointer is a very important thing. Here, whenever we'll write programs, the program for stack, the program for queue, the program for tree, and linked list. Basically, we have to play with pointers. Again, I am repeating, basically, we have to play with pointers. So pointer is very important. Okay, next, course outcome. So what course outcome means? After completion of this course, what you will gain, what you will earn. So on completion of the course, students will able to learn, understand and principles of linear and non-linear data structure. So after 2 or 3 slides, I will discuss what is linear data structure and what is non-linear data structure. So after completion of the course, you are able to understand the exact principle of linear and non-linear data structures. Number 2, identify appropriate data structure and algorithm methods in solving problem. So basic objective is to solve a problem. To solve a problem. So for suppose P is a problem. Now for solving that problem, we have to first design algorithm. Okay. Now once algorithm is program independent, once you have designed or developed the algorithm, then your objective is to write the code. Now that code you can write in C, that code you can write in C++ or Java or Python or so on. But here you have to write the program in C. Now the thing is that here the thing is there appropriate data structure. So we have so many data structure, but for a particular problem which is appropriate, that you have to identify. That means after completion of that course, students are able to identify or detect appropriate data structure for appropriate problem. Number 3 is also very important. Discuss the computational efficiency of the principal algorithms for sorting, searching, hashing. Not only that, for trees, queues, stack, and all. Here, your objective is to analyze the computational part of the program. Now, for a particular algorithm, there are so many ways by which you can implement that algorithm. But you have to implement the algorithm in such a way that the time complexity as well as the space complexity will be minimum. Now, this data structure or any programming language is not the core subject of computer science. Nowadays, civil guys, electronics, they also can write programming. So what will be the difference of you people and them? The basic difference is that as you were from computer science background, you have to know what is the minimum or optimized way to implement the algorithm or implement the algorithm. We have so many methods, so many types of algorithm that also I will discuss, but that is basically in your 4th semester. Okay, now here some part is there for algorithm and most of the part is there for data structure. Next, these are the books that you can follow. Here, number 5, data structure, written by Lipsus, a very good book, very old book you can take. Number 6, data structure using 3 by Rima Treja. It's a very new one and it's a complete book. You can bring that book also. All the other book is also there, data structure to see by Jasbant Kanitkar or any other books. Now bring any book from the market, any book and do my classes properly. If you do my classes properly, no book is required. No book is required. But you can bring any book from the market and that book you can read. No issue. Next, I will start the topic. Here the name is data structure. Two things are there. First one is data, second one is structure. So what data means? The term data means a value or a set of value. Suppose my name is what? Bidesh Chakraborty. So I have my first name, I have my last name, though my middle name is not there. So this is what? It's a set of value because first name that is Bidesh, last name that is Chakraborty. So data means what? A value or a set of value. Now a value means what? As I am an employee of HIT, so I have an employee code. As you are a student of HIT, so you have a roll number, and that roll number is unique. That means it's a single value. So data in raw sense, data is basically a value or a set of value. So what data structure is? What data structure is? Come here. Just follow this one. Just a minute.
স্যার
Yes.
স্যার আপনার থেকে স্যার 2 মিনিট স্যার সময় চাইছি স্যার আমাদের স্যার এখনো স্যার 30 জন স্যার স্টুডেন্ট স্যার ওয়েটিং এ আছে স্যার
Now what can I do now? Already it's to 10:28.
স্যার যদি
I
স্যার
will
2
take
মিনিটের জন্য যদি
just a minute. I will take another one class. Okay, for the same topic.
ওকে
For
স্যার
those are not currently present here. Okay.
ওকে স্যার
Okay. Now, data structure. So, just follow this line. Data structure is a mathematical model to organize or to store data in such a way that we can insert, delete, update the list very efficiently. Very efficiently. Here in computer science, a data structure is a data organization, management, and storage format that enables efficient access and modification. Now, one question may come in your mind, why so many data structures? If our objective is to store the data, then why so many data structures? Yes, we have so many data structures. Now, I am giving you one real life example. Suppose we have a water, say water is a data. Now, where we can store the water? For storing water, basically we use some bottle. Suppose we have the rice. Now, where we can store that rice? We can store that rice in a thali. Similarly, suppose we have a chicken curry or mutton curry or fish curry. Where we will store? We'll keep that chicken curry or mutton curry in a bowl. So there are several structures where we can store water, rice, and chicken curry. Now we can keep water in thali also. We can keep, but we cannot use efficiently. Is that clear? Is that clear?
Yes, sir.
Yes, sir.
So,
Yes, sir.
that's why we have different data structures to store or manage different data in such a way that we can access efficiently. So access efficiently, it means what? We can insert the data, we can delete the data, we can search the data, we can traverse all the data efficiently. So that's why data structure is nothing but a mathematical model to organize or store data in such a way that we can access efficiently, or we can insert, delete, update the data values efficiently. Now, next, classification of data structure, which is very important. So basically, we can classify data structure into two categories. First one is primitive data structure. Everyone knows that primitive data structure. The examples are integer, character, float, and boolean. And the second one is non-primitive data structure. And in this semester, basically we'll discuss all the non-primitive data structures. Here in non-primitive data structure also, we have two categories. First one is linear and second one is non-linear. So linear means what? Linear means what? Where the data stored linearly or sequentially. Here the examples of linear data structures are array, linked list, stack, and queue. I will discuss every one by one. And I think all of you know array. So can you tell me what is array? Anybody? Anybody? What is array? Anybody?
Sir, a collection of same data type object.
Exactly. Collection of same data, or we can say collection of homogeneous data. Now, non-linear. Here, non-linear examples of tree and graphs. Now, I will discuss one by one what is linear data structure and what is non-linear data structure. So, primitive data structure, I think all of you know. Non-primitive is what? These are most sophisticated data structures. Most sophisticated data structures. These are basically derived from primitive data structure. This point is very important. So non-primitive data structure basically built by the primitive data structures. The non-primitive data structures emphasize on structuring of a group of homogeneous for array and or heterogeneous data items for structure. A non-primitive data type is further divided into linear and non-linear data structure. So what is linear data structure? A data structure is said to be linear if its elements are connected in linear fashion. The element is connected in linear fashion by means of logically or in sequential memory location. In case of array, already we have seen, you know that the elements are stored in sequence of memory locations. But in case of linked list, we have to see the elements are stored not sequentially, but the sequence come from, or the linearity come from by their logical sequence. By their logical sequence, I will discuss. There are two ways to represent linear data structure. One is static memory allocation, that is using array, and another one is dynamic memory allocation. So do you know how we can allocate memory dynamically? There
No,
are
sir.
so many functions. Basically, three functions are there. Have you ever the functions? The name of the functions are malloc, calloc, and realloc. Again, I am saying malloc, calloc, and realloc. These three are the function. These three are the function. These three are the function by which you can allocate memory dynamically. Now, the possible operations of linear data structure. What are the operations that we can perform on data structure? The operations are traversing, insert the element into your existing data structure, delete one element from your existing data structure. You can search one element from your existing data structure. You can sort all the elements either ascending order or descending order from a existing data structure, or you can merge two data structure. Suppose we have data structure that is D1 and another data structure say D2. We can merge these D1 and D2 also. And here the examples of linear data structure already I have said, that is array, linked list, stack, and queue. Next, non-linear linear data structure. Okay, fine. Examples. Now come to the examples. So stack, already you know array. Now here array, stack. So first of all, you have to understand what is stack. Stack is a linear data structure. Fine. What kind of linear data structure? In which insertion and deletion operation are performed at one and only one end. Where insertion and deletion operation are performed from only one end. Now I am giving you that example. Suppose this is the example. Say here, what is it? This is the plates. Now, if you want to take the plate, any plate, how you can take that plate? Always you take the plate from the top. Is this clear? Similarly, if you want to keep plate here in this data structure, how you can keep? You just keep the plate in the top. That means it's a linear data structure where insertion, that is basically known as push here, and deletion, that basically known here pop. So insertion and deletion both take place from one end. Is this clear? That's why we can say that, or another name of stack is last in first out, that is LIFO. Is this clear? Suppose I have a single plate. So I take that plate here. Now I want to keep another plate here. So how I can keep it? I just keep on the top. Next time, next plate I keep here. Next time, next plate I can keep here. And after that, for deletion, if I want to take one plate from the stack, so how we can take it? We just take this one. After that, we just take this one, and here we just take this one. So is this clear? So it's a linear data structure where insertion and deletion can take place from a particular end. From a particular end. So what is there in the stack? There is an array. This is one array, and this is your one variable that holds the top position. Initially, say this is one array. I am giving you one example. Say this is one array. Initially, say this is one stack. Initially, the stack is blank, empty stack is there. Now, say you want to insert 5. Okay, so 5 is inserted here. Initially, your top will be, initial value of your top will be, say, -1. Now, whenever you push 5, now top presents here, your top will be what? 0. Next, suppose you want to insert 6. So where you will insert? You will insert 6 here. Your top will be what? The value of top will be top plus 1. That means top points here. So top will be now 1. Now for insertion of 7, your top points here with the value 2. Say now insert 10, your top will be with the value 3. Clear? Now if you want to pop 10, so after pop of the element or after deletion of 10, your top will be again points here. That means the value of top will be 2. Similarly, after popped of 7, your top will be 1. And then after popped of 6, your top will be 0. After popped 5, your top will be -1. That means it's a kind of container where one end is left blank, and you can insert the element from that end, as well as you can remove that element from the stack from the same end. So this is the end where you can push the element into the stack. Similarly, this is the end where you can pop the element. And top is what? Top is a integer variable that holds the topmost position of the stack. So stack is called last in first out because the element those comes last in the stack will pop fast. Is this clear? Why this is last in first out? The element come last into the stack is popped fast. That's why last in first out, or we can say LIFO, or we can say LIFO. So this is all about the basic of stack. Now I will discuss very basic of queue also. Now, like stack, queue is also one example of linear data structure. What kind of linear data structure is it? In case of stack, we have seen we have only one end. From there we can push something and we can pop also. Now in case of queue, there are two ends. In one end, we can insert the data into the queue, and another end, we can delete the data from the queue. So the real life example, so this is your queue. So this is the example of a queue. Any railway reservation system, real life example of queue here, this is library counter, any kind of counter where we can maintain a line, it's an example of queue. Now here two end is there. One is this end and another one is this end. So this end is basically rear end from where we can insert the data into the stack. Suppose you are in the library and your objective is to go to the library counter. So the queue is already there. So you have to come here. That means, sorry. the data is inserted in the rear end, and here this is the front end where the elements will be deleted. So here take that example. So initial value of front is 0 and initial value of rear is also here is -1. Rear is also -1 like top in stack. So first 10 is inserted from here on that time, rear will be 0. Next 20 will be inserted there, rear will be 1. 30 is inserted there, rear will be 2. Now say let's assume 40 will be inserted there, your rear will be what? Speak out please. 3. Now 50 will be inserted here, your rear value will be 4 and so on. And whenever deletion is occurred from the front side, suppose if 10 is deleted, then your front will be 1. After that 20 is deleted, your front will be 2. 30 is deleted, your front will be 3 and so on. Now the another name of queue is what? FIFO, that is fast in fast out. Element that comes first into the queue is always out fast. Elements that comes first into the queue always delete or out fast. That's why this is FIFO, fast in fast out. So the basic difference of stack and queue is that stack maintained LIFO structure, whereas queue maintained FIFO structure. Though both are linear data structure. Though both are linear data structure. Next, linked list. So what linked list is? We know array. So array is what? It looks like. Say some cells are there one by one, where we can store the homogeneous data. Say suppose the integer array 5, 6, say 1, say 9, say 15 and so on. Here let's assume that the address of the 0th element, so this is 0th element, this is first element, second, third, fourth and so on. Let's assume that the address of the 0th element is 1000. Now can you say what will be the address of next element? What will be the address of next element?
We cannot say.
A group of methods used for finding analysis to assign the greatest.
The next element is the address of the next element is 1002. It's an integer array. So the size of integer is 2 byte. So that's why, and this is what? Contiguous memory location for array. So that's why if this is 1000, it should be 1002, it should be 1004, 1006, 1008 and so on. That means elements are stored in contiguous memory location. Now, in case of linked list, the elements are not stored in contiguous memory location. Again, I am repeating that term. The elements are not stored in contiguous memory location. Suppose here, if this is 1000, suppose the address of 2 is say 8000. Suppose the address of 3 says 9000 and so on. Now, how we can say it's a linear list? How we can say? Because in case of linked list, first of all, we have to create a node. This is one node, and every node has two parts. This is the data part, and here this is the address part. And in address part, it basically stores the address of your next node. That means 8000 is stored there. Similarly, 9000 is stored there. That means we can create the linearity based on what? Based on this pointer value, because first node contains the data 1 file. Now the next part of the first node contains the address of the next node. It means this is points to the next node. Similarly, this node points to the next node. So this is the way by which it can maintain the linearity in logical. Is this clear? So for each and every node, we have basically two parts. First one is the data part, where we can store data. Say 5 is. Suppose we have 5. Next, this is another node. It may have 2 parts. Now for 5 also, it has 2 parts. Now, in case of array, this is contiguous memory location. Here, this is not contiguous memory location, but the linearity comes from that pointer. That means this points to 6. What it means? It means, suppose the address is 1000 here for 6. It means this part holds the address of 6. It means logically the linearity came. Okay? Any question? Any question here? So now, can anybody tell me what will be? There are so many advantages of linked list over array that I will discuss. But what will be the disadvantage of linked list? Can anybody tell me? Can anybody tell me what will be the disadvantage of linked list?
Sir, data is scattered in different memory locations.
So what? So what? But the sequence has come logically. The main disadvantage is that here in array, for storing a particular data, it takes 2 bytes, because every integer takes 2 bytes. The size of the integer is 2 bytes. But here for storing each data, we have to create a node, and that node has basically 2 parts. So first part is for data, and second part is what? To store the address of the next node. That's why the storage here, it takes much more storage. Here it takes much more storage. Space is higher, the larger space it has taken here over array. But there are so many advantages of linked list over array. So many advantages. I will discuss one by one. Next, nonlinear data structure. Today I just give the overview. Already 10:51, I don't know. Another 5 minutes I think I will have. So nonlinear data structure. Examples of nonlinear data structure is what? Tree and graph. Now, the question is very interesting, and sometimes interviewer asks that question whenever he will sit for interview. What is the difference between linear data structure and nonlinear data structure? And the students basically say the examples. The examples of linear data structure is stack cube. The examples of nonlinear data structure is tree and graph. Okay, it's fine. But they basically want to listen the exact difference. The main difference of linear data structure and nonlinear data structure is, for linear data structure, for a particular data, there must be a unique predecessor. There must be a unique predecessor and a unique successor. Is it clear? In case of linked list, for a particular node, there must be a unique predecessor as well as there must be a unique successor. For array, any element, suppose you have an array ARR. Suppose 10 elements are there. So just consider ARR 5 for fifth element. There must be a unique predecessor, that is ARR 4. There must be a unique successor, that is ARR 6. But in case of non-linear data structure, for a particular data or a particular node, there may be more than one predecessor and there may be more than one successor. Is this clear? Is this clear? This is very important thing. This is very important point. For non-linear data structure, for each and every data or each and every node, there must be or there may be more than one predecessor and more than one or more successor. Now, non-linear data structure, already I have said. So here, the data are represented by a hierarchical order. Now here, suppose this is your level 0. In level 0, we have CEO. Now there are two successor of CEO, that is COO and CFO. So this is level 1. And here this is level 2. Now this is basically the parent of this. This is the parent, and here we can say this is the left child, and here this is the right child. Similarly, for COO, two child is there, one for accounting, another one for audit. For CFO, three childs are there, that is marketing, production, and IT. That means the data are represented in a hierarchical order, where each node there may be one or more predecessor and there may be one or more successor. That is non-linear data structure. Now the examples of non-linear data structure is tree and graph. So this is the example of a tree. This is the example of a tree. Suppose I can represent some data in a tree also, say 5, 6, 7, say here this is 8, say 9, and here this is 10. We have so many trees. First one is the binary tree. Next, I will discuss binary search tree. After that, I will discuss threaded binary tree, then AVL tree, then B tree, and then B plus tree one by one. These are all present in your syllabus, unit 3 of your syllabus. Now here, this is the example of binary tree. Why binary tree? Because each node must have either no children or one children or maximum two children. If that property follows, then the tree is basically known as binary tree. Is it clear? Binary tree. What I have said, each node, the child of each node is either 0 or 1 or 2, but not more than 2. That means we cannot say this is binary tree. Can you explain why this is not binary tree? Because in that node there are 3 children, but in case of binary tree, a node have maximum 2. Now the nodes which have no children is basically known as leaf node. So this is leaf also. Here accounting, audit, marketing, production, IT, these are all leaf node. And this node is basically known as root of the tree. So here this is CO is the root, and here we can say 5 is the root. And all other nodes like COO, CFO, or here 6, 7 are basically known as intermediate nodes. So basically three kinds of nodes are there in a tree. First one is the root, from where the tree will start. The nodes that are present in the last level, is basically known as leaf node. Mind it, leaf node has no children, and the nodes placed in between of root and the leaf nodes is basically known as intermediate nodes. So this is the example of tree. Now another data structure we have, that is graph. So what is the difference between tree and graph? Tree is nonlinear, graph is also nonlinear. The difference between tree and graph is graph contains loop. Here in tree there is no loop, there is no cycle, but graph there is cycle. So all trees are basically graph, but graphs are not tree. All trees are graph, but graphs are not trees. Is that clear? Because graph contains cycle or loop, but tree do not have any cycle or loop. Okay, so it's already 11. I think your next class will start from 11. So anybody who will use, I just stop my sharing here, and